Hey guys, welcome back to the 5th episode of the Magic Shooter tutorial. In this episode, we're going to be writing the scripts and classes that we need to set up attacks for the player. This episode is going to be very code heavy and we won't actually be playing in the editor at all, but we'll be able to put this all into use in the next episode. We'll be creating a structure that can be easily extended to create as many abilities like healing, attacking as we want. For this project, we have 2 different attacks, but this setup is intended to make setting up other abilities easier and cleaner. We'll use the data structure for a clean way to store data for the abilities, and an abstract class that will provide structure and consistency to our abilities. A parent abstract class will help us avoid rewriting the same code over and over again, since it will affect all of the classes that implement it. First, let's make the data structure. Inside the player folder for scripts, we're going to make a new folder for abilities. We'll create a new ability called AbilityInfo. The first step that we want to do is to make it serializable, meaning that it can be embedded into another class or have it show up in the editor. The next thing we want to do is to remove the mono behavior that all Unity scripts derive from by default. This is what allows Unity functions like start and update to be used. Since we're using this as a data structure, we don't need those functions. Now onto the variables that we need. We're going to have 2 editor variables, the power and the range of our ability. Power is not just limited to how strong our attacks are, but can be used to determine how much is healed or buffed if the ability is not an attack ability. We'll also be using some C# syntax to create a quick getter function so that the other scripts can have access to these variables. We'll create a new public variable for power and create a getter function that returns our editor variable power. We'll pretty much do the same for our range variable, borrowing the name, and then we're also using a float instead of an int for the range of the ability. Next, we're going to create our abstract class, which will simply be called ability. An abstract class is similar to our data structure, but instead of defining what variables we have for each ability, these create functions that will be used in each ability subclass. So to make the script an abstract class, add the word abstract in the declaration of the class. Then, we'll initialize some important variables. We want these variables to be protected, which is between private and public. It is still private to any class that is not a subclass of this abstract class. For example, one of the attacks that we'll be implementing later will be able to access all of the information in a protected variable, but no other objects or scripts can, since it will be private to those objects. We have one editor variable, and it's going to be the AbilityInfo data structure, since this is where all of the information is saved. We'll call this m_info. Next, we want a cached component for the particle system that will make it all flashy. Like with m_info, this will also be protected. In awake, we want to get particle system and save it to cc_ps. We want a basic function in our abstract class that all abilities will need, which is a simple use function, since all abilities will need some function to trigger it. It is also going to be an abstract function and will take in a vector 3 for the position of where the origin of the ability should be. This can be used or not, depending on the ability that is being used, but for our 2 attacks that we'll be using, they'll be very useful. Now that we've got everything set up, we're going to start with our first attack. If you remember from episode 1, one of the attacks that the player has is a normal laser attack that deals less damage. We'll get started with it now by making a script called laser attack. This script is going to be a subclass of the abstract ability class, so at the top, we're going to change mono behavior to ability. If you're using Visual Studios, you may notice that some red lines start to appear. This is because Visual Studio notices that we're implementing ability, but don't have any of its inherited functions, like use. We can either type it in, or use Control period and let Visual Studios do its job by implementing the abstract class for us. We can get rid of the exception because we'll be implementing the function right now. This laser will attack straight out of the player and deal damage to everything on its way. We have a few ways to do this. One is by using collision methods, and the other is raycasting. Raycasting shoots out a ray, or vector, to detect if there are any objects that will pass through it. Think of it like tripping a motion sensor. We're basically going to be using a special type of Unity raycast called a spherecast, which is basically a really thick ray. You can imagine it as a sphere moving through space. It'll detect anything within a radius of the sphere and its path, pretty much like an actual laser. For any raycasting, the first thing we want to do is initialize a raycast hit object, which will store any objects that are hit by the raycast. If you want to hit and store multiple objects, then make this variable an array. The spherecast itself, which we'll be calling using physics.spherecast, takes in 5 parameters: the origin of the array, the radius of the sphere, the direction of the ray, the raycast hit object we just made, and the max distance the ray will travel. Remember that we're passing in a vector 3 as a spawn position, so this will be our origin position. We could create a variable for the radius. The radius is going to be 0.5. For the direction, we'll have it going directly forward from the player, so we'll give it transform.forward, which is the forward vector from the parent transform. The next object we want to specify is the hit object. We specified that as the output, and then just pass in the variable we just made. And finally, we pass in m_info.range as a max distance. Spherecast will return a boolean indicating whether or not the raycast hit something. So we could take this entire spherecast call and put it into an if condition. If it is true, then we want to check the tag of the hit object. We can check this by accessing the collider and calling compare tag like we did before. If it is, we want to call the enemy's decrease health function and pass in the power of the laser attack from AbilityInfo. Next, we'll create the laser effect associated with the laser attack. What we can do is just call particleSystem.play to play the effect. However, we also want to scale this particle system by the actual size and length of the laser, and how far it's reaching to hit the enemy. So we'll create a var called emitter shape to store the shape of the particle system. We use var as an abstract type that could be any variable type. It should only be rarely used when you don't know the type of the element that you're storing, and we're using it in this case for shape. We'll set the length of this to the range of the attack, and then we'll call play. And that's it for the first attack. Now we'll create the stronger attack, the mega laser. This will be larger and can hit multiple enemies. This will be made similar to the first laser attack. We'll create a script called Mega Laser Attack and implement the ability class like before. In the raycast this time, we want to hit multiple enemies, not just the first one we find. So we want to create an array of raycast hits. And we'll call spherecast all this time. This will return everything that it hits and won't stop once it's hit something. It only takes in 4 variables as opposed to 5 though, because it doesn't need the hit variable to be passed through as the output anymore, since it returns an array instead of a boolean. Otherwise, the variables stay the same. Spawn position for the origin, a wider radius, so 1, transform.forward as a direction, and m_info.range for the length of the raycast. Next, we'll iterate through each object in the array that was hit, compare the tag like before, and call decrease health if it is of the tag enemy. For the effect of this laser, and since it hits all enemies within its path, we won't be shortening the laser effects at all. So we'll just set it to the original length of the range of the attack. We'll do the same setup that we had before with creating a var for the shape and changing its length. And now we have our 2 attacks all set up. The last thing we're going to do for this episode is attach these scripts onto the prefabs that we have set up. In the prefabs folder, you'll find 2 prefabs for lasers. On the laser prefab, we'll attach the laser attack script and set the power to 5 and the range to 10. We also want to set the tag to attack ability to denote that it's an attack, and we're also going to be setting the layer as well. Layers are like tags, except they're used for rendering and collision detection. We're also going to be attaching a destroy an X second script and set it to 4. Likewise, attach mega laser attack script onto the mega laser and set its values to be 10 and 25. We also want to set the tag and layer to attack ability as well as a destroy an X second script. We can also set that to 4. Make sure you save these prefabs, or just make sure that the autosave feature is on. As a recap, this episode we set up the data structure and abstract class to build our ability and hence our attack system. We set up 2 attacks for the player, a small laser and a mega laser. Since we still don't have a way for the player to call the attacks yet, we can't test them, but we'll test them in the next episode. In the next episode, we'll set up the attacks from the player's point of view and actually start being able to attack our enemy. Thanks for watching, and I'll see you in the next part.